the number system or the numerical system. We can say number system is also called as a numerical system. The numbers in this system have the base value 2, digits 0 and 1 are called the bits. So octal is nothing but the base value is 8 and it uses the numbers from the what? 0 to 7. So 3 I can written as a 0 1 1 and also 4 written as 1 0 0, 5 written as 1 0 1. Hello students, this is Asha, Faculty of Computer Science at Vidhyaashram First Grade Degree College, the Temple of Excellence, MYSURU. So let's discuss about the first session of the Unit 2, that is the number system. So in the previous sessions you already get to know what are all the fundamentals of the computers. So in today's session we are going to start up the Unit 2 first sessions. So here you can see the agenda of this session is you will get to know what do you mean by the number system and also types of the number system and interconversions and also ones and twos complement and also arithmetic operations of the binary number systems. So let's discuss one by one topics. So here you can see what exactly the number system. Before going to the number system you will get to know what exactly the number is. So here you can see the number system or the numerical system. We can say number system is also called as a numerical system. Both are the same. So the way of representing the numbers or presenting the numbers is called a number system. It can be digits and also position. It could be matter and also the base of the number system. If I write a number inside the parenthesis, I have to write a base or the radix value, that is 8 or else we can say 10 or else we can say 2 or else we can say 16 or else we can say 3. These are all some of the base value or the radix value which could be represented. Why? Because we need which number. This number belongs to which number system. So that's why the base or the radix value, it could be matter. So here you can see before discussing the different types of the number system, we will get to know what exactly the number is. Right? So here you can see a number is a mathematical value. A number is nothing but value or the digit, right? So a number is used for the counting or measuring, labeling objects. So the number is nothing but the mathematical value or the mathematical digit. So let's discuss one by one number system. So here you can see the pictorial representation of the types of the number system, which will be the positional number system. So these are all come under the positional number system. There are mainly two types of the number system, non-positional and also positional number system. Under the positional number system, here you can see 4 types. There are mainly 4 types of the positional number system. The first one, decimal, binary and also octal and also hexadecimal. It uses only base value 10, 0 to 9 and also base 2 and 0 and 1, and the octal is base value is 8 and also it uses from the 0 to 7. Last one is hexadecimal. It uses the base value called 16 from the 0 to 9 and also A to F. So here you can see the first type of the number system, that is what? The decimal number system. As I already told, it uses what? Base number 10. So here you can see the definition. Decimal number system has a base value 10. It uses from the 0 to 9. You have to concentrate which are all the digits is used by the decimal number system. So here you can see one example. What is that? 1457. So in decimal, the position, the name will be say as a positional number system. Why? Because we have to concentrate on only what? Positions. So here you can see this is in a unit position, this is in a 10th position, this is in a 100 position, this is in a 1000 position, right? So that's why we read this number as 1457, right? So that's why here you can see one example, that is 1457. We can write like this. Why? Because 7 in a unit position. This is the base value 10, right? That's why I use a 10 as a base value. 10 power 0 or any number power 0 could be a 1. 10 power 0 could be 1. That is unit. So 7 into 10 and also the next digit is 5. We have to read from the left to right. So that's why 5 into 10 power 2 and the third digit, that is in a 100 position. 4 into 10 power 2 is nothing but 100. And also lastly 1 into 10 power 3. So here you can see I brief 10 power 3. 10 power 3 in normally 10 power 3 is a 1000, right? So that's why 1 into 1000, 4 into 100 plus 5 into 10 and also 7 into 1. So we have to combine all these multiplication into the summation. So that's why I use a plus here. So lastly, I can say 1000 plus 400 plus 50 plus 7. We can say 1457. That is the answer. This is how we have to represent any number using the decimal number system. So go to the second, that is what? Binary number system. So here you can see binary means the base value is 2. It uses only what? 0 and 1. This is you have to concentrate. So here you can see the numbers in this system have the base value 2. Digits 0 and 1 are called the bits. So 8 bits together make a byte. So 8 bits is nothing but 1 byte, and also the data in the computer is stored in terms of bits and also bytes. The computer will be understand only by the zeros and ones, right? So that's why. So here you can see the examples of the binary system. It could be only contains the zeros and ones, not a 2, 3, 4, 5 and all. So that's why the number consists only zeros and ones. We can say that number belongs to the binary number system with the base value. You don't forget the writing of the base value. Without the base value, the number is invalid. Why? Because we don't know the number belongs to which number system. So that's why base value is the important one. So here you can see some more examples of the number system. So let's see one solutions of the example. So here you can see one example of the binary number system again. I take an example like 1011 with the base value 2, right? So the pictorial is represented like it uses only base value 2 and it uses only 0 and 1 digit. So I already told which is in a 0th position, 1 position, 2nd and also 3rd position. So it uses only base value 2, right? So that's why 2 here. Got it? So here you can see 1 into 2 power 3. Why? Because so here you can see 1 belongs to the 0, 1 belongs to 1, 0 belongs to base value 2. This is how you have to represent 1 into 2 cube, 0 into 2 power 2, 1 into 2 power 1, 1 into 2 power 0. So here you can see 1 into 2 power cube. 2 power cube is nothing but 8, right? 1 into 8, that is 8, 0 into anything 0, plus 1 into 2 means 2. 1 into 2 power 0 could be 1. So when I finalize the result, it could be 8 plus 3 is 11. With the base value what? 10. This is how you have to represent the binary number. So let's discuss about another number system, that is what? Octal number system, which uses 8 as a base value. So octal is nothing but the base value is 8 and it uses the numbers from the what? 0 to 7. Not 8, 9, 10 and 11. So here you can see one example of convert the 215 with a base value 8 and also into the decimal. So how to convert? Write a 215 with a base value 8. So I already told 215 which is in a 0, which is in 1, which is in 2. So which number belongs to the octal, right? So that's why I use the 8 here. Got it? So which is in a 0th position, which is in a 1 position, which is in a 2 position. That's why it all belongs to the positional number system. So 2 into 8 power 2, 1 into 8 power 1, 5 into 8 power 0. When I combine all this, 2 into 8 square means 64. 2 into 64, 1 into 8 and 5 into 1. So when I combine all this result together using the plus 128 plus 8 plus 5, I got the result as what? 141 as the decimal value. So let's discuss about the another number system, that is hexadecimal number system. So here you can see the number system with the base value 16 is known as the hexadecimal number system. It uses from the A to F and also from the 0 to 9. So here you can see 0 to 9 and also A to F. So here you can see one example 7b I can written as a with a base value called 2. I can convert any number system into the base value 2. So let's discuss the interconversions. Interconversions is nothing but the converting any number system into the another number system or required number system. So 16 is a hexadecimal number, so I can convert into the binary number system and also binary to the hexadecimal. These are all called the interconversion. So here you can see the conversion process from other number system, that is binary, octal, hexadecimal and also decimal to the decimal number system as the same procedure. Here any binary number can be converted into equivalent number system. So here you can see one example. I can write one example, that is binary to hexadecimal. So for binary to hexadecimal, I need a binary number, right? So that is what binary number. That is what binary number which contains only zeros and ones, right? So with a base value 2. And also how to convert hexadecimal. Hexadecimal is nothing but, so I already told, this is in a 0th position, this is in a 1, this is in a 2, this is in a 3. When I combine all these, so you can get a 15. 15 as the number. That is what the highest means A to F, and also 0 to 9. So here you can see this is what 15. So A to F means A starts from the what 10, B 11, C 12, 13 and also 14, 15. So this is B, C, D, E, F. Got it now? This is how you have to write a hexadecimal. Why? Because hexadecimal I have to contain only 4 digits of number. So that's why I group a 4 numbers. How it can be possible? So here you can see the numbers. It could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 10 digits are there under the binary number system, right? So you have to convert the from the left to right 4 digits you have to mark first. Then another 4 digits. And last you will get only 1, right? So put a 0, 0. 0, 0. That is what the result says. 0, 0, 1, 1, 1, 1, 0, 1 and 1, 0, 1, 1. This is how you have to convert a what binary to hexadecimal. So again, when I convert, what could be this 0, 0, 1, 1 means 3. In binary, we can say, in decimal, we can say this is 3 and this is 1, 1, 0, 1 means what? Here you can see D is 13, right? So 1, 1, 0, 1 means D. That is what? 13. 13 I can convert into hexadecimal what? That is D. And come to this one, this could be B. Why? Because what is my B value? 11. So 1, 0, 1, 1 is 11. So that's why B is 11. So when I combine all these 3DB, you can get the hexadecimal with the base value what? 16. This is how you have to use a conversion. Got it? Let's see some more examples of the interconversion, so you will get to know. So here you can see binary to octal. So the number already given what? 111101101. So in octal it uses only from the 0 to 7. The highest bit could be 111, right? 111. So this could be written as a decimal value as a 7. So it uses only, so that's why I group a 3 bits. So here you can see from the left to right I group a 3 bits and again another 3 bits and last 3 bits. So that's why they return, I can return like a 3 bits. When I group all these, I combine what is 111 in decimal, that is 7, and also 101 is 5 and again 105 is 5 with the base value 8. This is how you have to convert the binary to octal. So here you can see another one example, binary to decimal value. They already given, but you have to carefully look at the problem. They already given the with a fractional point, that is 0.11. So you already know the scale, right? So scale in the middle 0, this side you get a positive numbers and this side you get a negative values. That is how it could be work. So here you can see with the position 1, 0, you have to concentrate this part. See here, this part you have to concentrate first, which is in a position 0, which is in a position 1, 2, 3, 4 and also 5. Got it? So that's why 1 into 2 power 5 plus 0 into 2 power 4, 1 into 2 power 3 and also 1 into 2 power 2 and lastly 0 into 2 power 1 and also 1 into 2 power 0. So after that you have to concentrate 0.11, that is the after the 0 you will get a negative values. So that's why 1 into 2 power minus 1 and also 1 into 2 power minus 2. Can we write 2 power minus 1 in generally. This could be written as 1 by 2 power 1, and also 2 power minus 2 we can written as a 1 by 2 power 2. Got it? When I solve all this, I'll got a result as 45.75. That is what my decimal value. Got it? So let's see some more examples of the interconversions again. So here you can see again decimal to binary. So decimal to binary, you have to convert what? Base value 10 to 2. So when I got a decimal value, that is a human readable format, that is what? 100. When I keep on dividing 2 into 5, I got a 10. 0 as it is, you have to put a 0 here, then you will get a remainder 0. When I divide, when I multiply 50 into 2, I got 100 with the remainder 0, right? Again, divide from the 2 again. 2 into 2, you will get a 4. 1 as a power. So here you can see 1. 2 into 5, 10. Again, remainder 0. When you keep on dividing all this, you will get a what? 1, 1 with the 0, 0, 1, 0, 0. That is what? Binary. When you got a decimal number, you have to convert it to a binary. You have to divide like this. Got it? So when I keep on dividing, I got a result 1, 1, 0, 0, 1, 0, 0. As a result with a base value what? 2. This is how you have to convert decimal to binary. So let's see some more examples. So here you can see decimal to again octal. So this is my octal number. So this is my decimal number. So they already given the decimal value. They are with the base value 10, and keep on dividing from the 8. Because why? Because I have to convert decimal to octal, right? So that's why you have to use a 8. When I keep on dividing, I got a remainder 0, and also here remainder 1, remainder 2. When I use like this, you have to get a 210 as a octal value. This is how you have to convert. So here you can see another example, decimal to hexadecimal again. You have to convert decimal to hexadecimal. So that's why I use a 16 as the divider. When I divide 9, 10, this is my what? Decimal value. You have to divide from the 16. When you keep on dividing, you will get a what? Remainder E, remainder 8, and also remainder 3. In hexadecimal, we already get to know A is 10, B is 11, 12, 13, 14, up to only 15. This is C, this is D, E, and also F. So what is my E value here? So here you can say 14. So the remainder is 14 here. So that's why in hexadecimal I can write 14 as a E. So that's why what you mean by 9, 10. From the 9, 10 with the base value 10, we can convert into the hexadecimal what? 3, 8, E. 3, 8, E with the base value what? 16, right? 16. You have to do like this. Got it? So let's see another example. So here you can see octal to binary. So from previous slide we already get to know binary to hexadecimal, binary to octal, binary to decimal. In the previous slide we already get to know what are all the conversions. So here you can see octal to binary. So octal to binary is nothing but they already given the octal number, that is 345. So you have to already say octal means you have to make a 3 bits of the group. So 3 I can written as a 0, 1, 1, and also 4 written as 1, 0, 0, 5 written as 1, 0, 1. So when I combine all these, I got a what? Octal number to binary 0, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1. This is what? My octal to binary. Got it? So here you can see another pictorial representation, octal to decimal. You already done octal to binary is already over, right? Octal to decimal. They already given same number taken, you can convert into the what? Decimal with a base value 10. So again 3 into 8 power 2, 4 into 8 power 1, 5 into 8 power 2. So why? Because they already given octal as a base value, right? So that's why I take a 8 power 2, 8 power 1, and also 8 power 0. Why? Because here you can see 345, which is in a 0th position, 1 position, 2 position. I have to convert from octal to decimal, right? So that's why 8 into 2 power 2, 8 into power 1 and also 8 power 0. When I combine all this could be 198 plus 32 plus 5. Anything power 0, any number power 0 means you will get a 1 as result. When I got 229 as the decimal value. So here you can see. So let's see some more examples of the interconversions again. So here you can see octal to the hexadecimal. You already get to know octal to decimal, octal to binary. This is what octal to hexadecimal. From the base value 8, you have to convert into the 16, right? So here you can see they already given the example 752 converted into the 16, that is what 1EA. So how can we convert? So write down the 752. So each bit which is from the octal, right? I have to convert into the hexadecimal. Hexadecimal I can represent up to only 4 ones. Why? Because 15 is the highest bit, in the highest digit in the hexadecimal. In octal we can say 111 is the highest possibilities, that is 7. So that's why first you have to write down that is whatever the octal number you have to write down in the octal system, that is 111. 7 I can written as a 111 and also 5 I can written as a 101 and also 2 I can written as a 010. Got it? So when I combine all these, I have to group of 4 bits each. Why? Because I have to convert octal to hexadecimal, right? It's already written in a octal. I have to convert into the hexadecimal. So that's why you have to convert 4 bits. 1010 means that is 10. That's why I can written as a. That is what? 10. In hexadecimal 10 is represented as A, right? So again 4 bit 1110, that can be written as 14. That can be written as what? E in hexadecimal. And as it is last is 1. So that's why 1EA. Got it? This is how you have to convert. And this is also 3641. It can be converted into 7A1. So and lastly 67,364. This is how you have to convert into 6CF4 as the base value 16. This is how you have to convert into the octal number system into the hexadecimal number system. So let's see one more example, hexadecimal to binary. Hexadecimal to binary, they already given the hexadecimal value 36F. I have to convert into the binary. It will be easy, right? Why? Because you have to 36F, right? So what do you mean by F is 15. So 15 I can written as a 1111. I have to convert hexadecimal. From hexadecimal I have to convert into binary, right? So that's why 6 I can written as 1100. So this is how you have to, in 3 I can written as a 101. This is how you have to convert. So that's why 111. This is how you have to convert. And again 1CED. It could be converted into the what? Binary value. And also last CAFE89 you have to convert it to the base value 8. This is how you have to convert from the hexadecimal to binary. Got it? So let's see some more examples. Again hexadecimal to decimal. So hexadecimal they already given the number 2A. So 2A is nothing but I have to convert to the decimal. So it could be in a hexadecimal format, right? So which is in a position 0, which is in a position 1, which is in a position 2. So that's why 16 power 2, 16 power 1, 16 power 0. So A means in decimal I can say 10 and also B means decimal 11. So 2 into 16 power 2, 10 into 16 power 1, 11 into 16 power 0. And also 2 into 16 power 2. It could be 512 and also 160 and also 11. When I combine all this using the plus operator addition, I can get a 683 as a decimal value. So here you can put a decimal value as the base or radix value. Got it? So here you can see another hexadecimal to octal. So example, convert 1BC with a base value 16 into octal number, that is what? 8, right? So solution here you can see 1BC is a hexadecimal number. So 1 means hexadecimal I have to represent using the 4 bits, right? So that's why 1 can be written as 0, 0, 1. B is what? 11. So 11 I can written as a 1, 0, 1, 1. C is 1, 1, 0, 0. So here you can see, now group them from the left to right. I have to group from the left to right. So that's why 0, 0, 1 means I have to convert into the 3 bits. Why? Because I have to convert hexadecimal to octal. Hexadecimal means I have to represent the number using the 4 bits and convert it into the octal, that is 3 bits. So that's why group here 3 bits and again here 3 bits and again here 3 bits and lastly you will get a only 0. So that's why 0, 0, 1, 1, 1, 1, 0, 1, 1, 0, 0, 0. When I use this in a decimal, 0, 0 means 0, 1, 1, 0 means 6, 1, 1, 1 means 7, 1, 0, 0 is a 4. When I combine all this, I got a 674 as the octal number. Got it now? This is how you have to convert a one number system into the another number system. These are all some examples you can convert, and also you can practice some more examples. In the class notes also I already do it. So you can convert any number system into the number system. You can make practice. Got it? So let's see arithmetic operations. So in generally arithmetic operations are nothing but the what? Addition, subtraction, multiplication and also division. Division, right? So these are all some basic arithmetic operators. So that is what used in a digital electronics. That is what the binary. We can only solve using the binary number system. So here you can see the fundamental aspects of binary arithmetic are addition and also subtraction, binary multiplication and also binary division. Why they used only binary numbers means 110 is rather than the, it is also easy for the calculation. So that's why they are using only for the binary addition and also multiplication, subtraction, division. Got it? So let's see examples of the binary arithmetic operations on the binary number system one by one. So here you can see the binary addition. So binary addition is nothing but a easier decimal addition when you remember the following tricks. So before going to the binary addition, we have to follow some rules. Then only we can solve the addition of the numbers. Got it? So here these are all the rules. When two values or two variables are 0, you got a result as 0. When two variables are in 0 plus 1, you got a result as 1. 1 plus 0, you got a result as 1. When you have a two variables 1 each. So 1 plus 1 is a 0 with the carry 1. When you consider like a 1 plus 1 plus 1, in this case you will get a 1 as a result and also carry as 1. Got it? When you have triple 1 or the variables contains all the variables contains all the three variables contains 1 each, then you will get a result as 1 and also carry also 1. So let's see some examples, you will get to know. So here you can see I consider this is A variable, this is B variable. With the plus operator I have to addition because this is binary addition, right? So here you can see 1 1 is 0. Why? Because here you can see 0 with the carry 1. 1 1 0 0 is again 1 and also 1 1 is 0 with the carry 1. So that's why result 1 0 1 0. Got it? So here you can see another examples. So 1 1 is 0 with the carry 1, 1 1 0 with the carry 1 and also 1 1 0 with the carry 1, 1 1 1 0 with the carry 1, 1 1 0 with the carry 1. So these are all some carries. These are all the carries. So that's why the result 1 0 0 1 0 0 0. So this is how you have to do the binary addition. So the next is binary subtraction. So binary subtraction, again we have to get to know what exactly the binary subtraction is. Nothing but the normal decimal subtraction, but we have to follow some rules. So this is the rule table. When you have 0 minus 0, you will get a 0. 1 minus 0, you will get a result as 1. When you have 0 minus 1, so then only you have to, the result could be 1 with the borrow from the higher bit. That is also 1. 1 minus 1 as usual, 1 minus 1 is 0. So let's see one example. So here you can see 1 minus 0. So what is the result? 1. You got. And again 1 1 1 0. 1 minus 0 again 1. 1 minus 1 what? 0. So again here you can see 1 minus 0 is 1. 1 minus 1 0. 0 as it is 1. 1 1 0 0 1. So here you can see 110 minus 101, 0 minus 1. So I already told you have to take a borrow with the result 1, right? So because in the 0 we can't subtract the 1. So that's why take a borrow from the higher bit, that is what 1. So when I take 1 as a borrow result, here there is nothing here. So that's why 0 minus 0, 0, 1 minus 1, 0. So and lastly 110, 101. So this is what the result you got for the subtraction. And come to the binary multiplication. So binary multiplication, like other binary operation, is much easier. Like the decimal multiplication, we have to follow some rules. So here you can see when two variables have 0, you will get a result as 0, and also 1 into 0 you will get a result as 0. 0 into 1 you will get a result as 0. 1 into 1 is a 0. Anything multiplied by 0 you will get a 0, right? So that's why when you have both the variables 1, 1, then only you will get a result as a true, that is 1. So let's see, look at some examples. So here you can see the examples. We have to multiply 1, 1, 1, 0, 1 into 1, 0, 0, 1. So I have to multiply. So normal multiplication, for example, I have to multiply 2 into 36. So what is the value? 6 into 2 is 1 is power, and again 3 into 72. Right? This is how you have to do normal multiplication, like how you have to do the multiplication. First you have to multiply from the 1, 1, 0, 1, 1, 1, and again you have to put a subscript here. Again from the 0 you have to multiply. From the 1 you have to multiply all the values, and also from the 0, and also from the 0, and also from the 1. This is how you have to do the multiplication. And lastly you have to addition. So for addition you already know the addition rules, means addition table. So apply for that. You will get a 1, 0, 1, and also 1, 1 with the 0, and also again 1 with the carry 1, 1, 1 with the 0. This is how you got the result for the binary multiplication. Got it? So here you can see these are all the partial products and placeholder. These are all we called as a placeholders, denotes as a carryover. 1 is denoted as a carryover. So here you can see 1 is carry. So this is how you have to do the binary multiplication, just normal multiplication like a decimal values. So let's see, the last one is binary division. So binary division is nothing but the binary division is much easier than the decimal division when you remember the following division rules. So here you can see these are all some 4 rules you have to remember while for doing the division, binary division. 1 by 1 is nothing but 1, and also 1 by 0, that is infinity or the meaningless. We can neglect 0 by 1, 0 into anything, or 0 by 1 it could be 0, and 0 by 0 is also a 0, or it could be meaningless. So let's see some more examples. So here you can see binary division. So here you can see this is first one, this is second one. From the 1, 0 I have to divide. Divide what? 1, 1, 1, 0. So first take a lesser bit. So you have to apply the binary subtraction for the binary division. You already know the binary subtraction rules. So 1 minus 0 is 1, 1, 1 is 0. So you can neglect and take a 1 bit as a, after that 1 bit again 10 into 1 means 1, 0 into 1. You will get a result as a 1, 0 is again 1, 1, 1 is 0. Take a second bit, and also like a third bit, and also like a fourth bit, and also like a fifth bit. So and lastly you will get a remainder as a 0. So you will get a 1, 1, 1, 1, 0 as the result for the binary division. So let's see the second example. So here you can see the second examples. 101. From the 101 I have to divide 1, 0, 1, 1, 0, 1. At a time I have to take a 2 digits. So that's why I put a 2 zeros here. At a time I have to put a 2 zeros here. So here you can see 101, 101. You will get a 0 as the last result. This is how you have to do the binary division. Got it? So in the next topic we can discuss about the ones and twos complement of the binary number system. So here you can see ones complement. So ones complement is nothing but the converting any 0 to 1 or 1 to 0. This is called as a ones complement. So for example, we have to use for this, we have to use only zeros and ones. So if a 0 is there, I have to convert into ones complement, it could be 1. If 1 is there, I have to convert into ones complement, this could be 0. Anything 1 you have to convert to 0 or 0 to 1. This is called a ones complement. So let's see the definition. To get ones complement of a binary number, simply invert. Invert means convert 0 to 1, 1 to 0 given number. So for example, ones complement of the binary number system. So here you can see 1, 1, 0, 0, 1, 0. So what is ones complement? This could be 0, 0, 1, 1, 0, 1. This is what the result. Got it? So here you can see some more examples which in a table. So 000 means 111, 001 means 110, 010 means 101, and also 011 is a 100 and 100 is a 011, and also 101 is 010 and 110 that is 001. 111 again it could be converted into 000. So 000 is 111. This is how you have to convert a ones complement. Any 0 to 1 and also 0 to 1 and also 1 to 0. This is how you have to convert the any number or binary number into the ones complement. Got it? So let's discuss another, that is twos complement. So here you can see twos complement is nothing but after getting the ones complement result. So for example, I got a result like a 010. This is my original number. For ones complement 101. So for this result, neglect this result, I have to add a 1 to the LSB bit. So when I add 1 to the LSB bit, I can get a 0, 1. So this is my twos complement result. This is how you have to get a twos complement result. So let's see the definition. To get twos complement of the binary number system is ones complement of the given number plus 1 to the least significant bit. So least significant is nothing but this is the least significant, this is the most significant. So you have to add the 1 to the LSB. So for example, you already get to the ones complement this result. When I add least significant 1, so I'll get a result as 0110. So here you can see some more examples. So here you can see, so 010111010 I can convert into the ones complement, that is 101000101. When I add 1 to the LSB bit, this could be twos complement. This is in a twos complement. Got it? That is how you can convert. And another example, so here you can see this is binary original number. When I convert into ones complement, 000 is 111, 10 is 01, 100 is 011. So when I add 1 to the least significant bit, this is your twos complement result. This is how you have to convert from the any binary number to ones complement and also twos complement. In the next session, we can get to know subtraction using ones and twos complement. So this is how you have to do ones and twos complement before going to the subtraction of ones and twos complement. Thank you.